Welcome, and thank you for joining me on this presentation. Today I'll be discussing how to solve fires on ro-ro passenger ship weather decks and how to comply with the new Solas regulations and FSS code, which are expected to be enacted in May 2024. My name is Roger Barrett James. I'm an attorney and the general counsel for Unifire AB of Sweden. Unifire is a globally renowned manufacturer of marine firefighting equipment, including advanced remote control fire monitors and fully autonomous robotic fire suppression systems called the Flame Ranger. Let's start with the problem that I'll be addressing today, and that is ro-ro passenger ship weather decks. Here you see a typical weather deck on a ro-ro passenger ship. And as you can see, during transit, the weather decks are very tightly packed with cars and freight trucks full of combustible cargo and often refrigeration units and other fire hazards. If a fire breaks out on a weather deck, there's an enormous amount of both fuel and air, which can lead to extremely fast, exponential spreading of fire from one vehicle to the next. And if a fire is not detected and suppressed very, very quickly, then it can get completely out of control and can cause catastrophic damage, fatalities, and even a total loss of the vessel. The primary causes of fires on weather decks are the cargo itself and refrigeration units. And when it comes to fire, time is the enemy. And that is because fire grows exponentially quickly when there's sufficient fuel and oxygen, both of which are abundant on a loaded weather deck. None of us is really able to get our heads around what exponential fire growth looks like. Here's just a couple of snapshots from a fire that broke out at a football match in England in 1985. That ended up killing 56 people. You can look this up on YouTube and watch for yourself. In about 3 minutes, the fire goes from very small, easily managed, to engulfing the entire stadium. Here in the upper left, you can see what the fire looks like when it starts. It's very small in the upper sort of middle section of that first slide. After 30 seconds, it's grown a lot, but is still manageable. After 60 seconds, it doesn't look that much worse, but after just a minute and a half, you can see it's a raging fire, and after just 2 minutes, it's engulfed most of the bleacher section. And here you see what it looks like after 3 minutes. Just absolutely explosive, exponential growth. So that's how fast fire can spread. Another example, one of many. This is a fire that broke out in an 8-story car park or parking garage in Liverpool in 2017. It took the fire brigade approximately 16 minutes to get to the fire from the time it was first detected. There were no sprinklers, and they were unable to suppress that fire. The entire building was a complete loss, and all 1,150 vehicles that were in the parking garage. This is quite analogous to what a weather deck fire is like, because you have tightly packed vehicles. And in fact, on a weather deck, it's even worse because the vehicles are parked bumper to bumper as well. If you can get to the fire fast enough, then even a small amount of water can extinguish it. So it's crucial to begin suppressing a fire absolutely as quickly as possible from the time it starts. And that key to doing that is to detect it right away and to start suppressing it right away. Based on our discussions with a number of ship owners and operators, the average time it takes the crew to begin suppressing a fire from the time they detect it is something like 5 to 12 minutes, with an average of around 8. And again, here's what the fire might look like after just 5 minutes if the conditions are conducive to that fire spreading so rapidly as they typically are on a weather deck. So you don't have 5 minutes to wait. A crew certainly cannot fight a fire of this magnitude. Just one more example. There have been numerous devastating fires on ships, of course, most of which break out in the car decks below, but a number have also broken out on weather decks. Here's a photo of a fire that broke out on deck 4 of the MS Norman Atlantic. This was in December 2014. There were 475 people on board, and this fire ended up killing 28 people, and the ship was a total loss. So again, the solution is detect that fire right away and put lots of water on it immediately. Now I'll go over some key findings of a recent 3-year study that specifically looked into fire safety on ro-ro passenger ships and state-of-the-art equipment and techniques for improving fire safety on those ships. This was the LASH FIRE project. You can learn more about it at lashfire.eu. It's the most recent and comprehensive study done to date. It just concluded in August of 2023. The findings have been submitted to the International Maritime Organization, or IMO, which is the body of the United Nations that regulates fire safety measures on ships under the Solas regulations and Fire Safety Systems Code, also called the FSS code. So these LASH fire findings that I'll present here may very well result in further enhancements to the Solas regulations and the FSS code beyond the new ones that will be coming into effect in May, which I will also summarize shortly. Here I'll only be addressing the findings of the study with respect to the weather decks, weather deck fire safety and fire detection, but there is a wealth of information on many aspects of fire safety on ro-ro passenger ships. So if you have interest in those other aspects, I recommend that you look at those reports. Again, they're at lashfire.eu, and I will be happy to also provide more information if you have questions. Unifire was a partner in the fire detection and fire suppression work packages for the weather deck fire safety in the LASH FIRE project, and I'm one of the co-authors and editors of those LASH FIRE reports relating to the weather deck fire safety. The key takeaways from the LASH FIRE project regarding weather deck safety are that the objective is to suppress, contain, and cool any fire that breaks out anywhere on the weather deck. In terms of how you detect the fire, the study recommends that triple IR flame detectors be used as the primary detection device. It also recommends that there be a supplemental thermal imaging camera system for crew's situational awareness, but that not be the primary alarm signaling device because thermal imaging cameras often can experience false alarms. I'll talk more about that in a second. Of course, the detectors need to be mounted up high so that they get a full view of the weather deck. In terms of the fire monitors, they should be remote controlled and not physically manually operated. They should be 2-inch fire monitors made of stainless steel 316L or an equivalent material that is appropriate for the harsh conditions on a weather deck. Again, they should be remote controlled, not manually operated. There should be redundant remote control devices on the bridge and other safe locations so that they can easily be controlled during a fire from a safe position. They should have a flow of at least 1,250 liters per minute at 5 bars of pressure. There should be double coverage of the fire monitors for every section of the weather deck so that you get suppression from 2 different angles. That's important for 2 reasons. For one, windy conditions are usually experienced on weather decks, and by having 2 fire monitors attacking from 2 different angles, you are minimizing the effects of that wind, so that if wind is hindering the suppression by one fire monitor, it's likely helping or at least not hindering the other one from a different angle. Moreover, the fire monitors also need to be mounted up high so that they get a good suppression angle down onto the cargo on the weather deck, which often can be up to 4 meters for the lorries and freight trucks. So that means positioning them at 7.5 meters of height. Just a little bit more about the detection. Again, they should be triple IR flame detectors. And the reason for this is that flame detectors are looking for the actual visible signs or signals of a flame. So they don't react to heat. They're reacting to the visible wavelengths of fire itself. And they're looking at 3 different wavelengths, and they have algorithms that are ensuring that they're only seeing fire. When there is a fire visible to them, they react very, very quickly and have a very low susceptibility to false alarms, meaning they're not triggering an alarm if there's some heat buildup or some other hot source. If there's no visible sign of fire, they will not react. If there is fire, they react extremely quickly and reliably. These 2 flame detectors, it's worth pointing out that you can see on your screen now, are able also not only to tell that there is a fire, but are also able to give the coordinates of the fire. And that's crucial for a fully autonomous system, which I'll be discussing later, so that the autonomous system is able to then target the water onto the fire and around it. It needs to know where that fire is to do that. So these are 2 flame detectors that are able to do that. Undoubtedly, there will be more on the market soon. Again, as I mentioned, it's a good idea and recommended that there be also thermal imaging cameras that can support the crew to see if there's some hot sources, hot engines, or other buildup of heat over time, to get them to go out and investigate and see what's happening. But you don't want that to be triggering alarms. That is because thermal imaging cameras, again, they're designed to look at heat signatures. And it turns out that especially during loading and unloading of the weather deck, you often get hot sources such as hot engines, exhaust, and other sources of heat, which will trigger a thermal imaging camera alarm, but which in fact do not need to be addressed in terms of fire suppression. They're not a fire risk, it's just something that's hot. So this often becomes a nuisance for crew. They often turn off such systems during loading and unloading because of repeated alarms that are actually not a problem. So you don't want that to be the primary system, but it's a good idea to have just for crew to be able to see what's happening on the deck in terms of the temperatures of what's going on. Here you can see an example of how the fire monitors need to be mounted up high so that they have a sufficient angle to guide the water to a fire anywhere on the deck, considering that the freight trucks, again, can be up to 4 meters high. Here's another example. In this case, the fire monitors are mounted on the pipes which supply them with water. Unifire works with each ship to design the most efficient and cost-effective positioning of both the fire detectors and the fire monitors to ensure both that they are going to be effective to suppress a fire anywhere on the weather deck, that there will be 2 suppressing from 2 different angles, and to ensure that they comply with the new Solas regulations and FSS code, as well as all of the recommendations in the LASH FIRE project. Here's just one other view to give you a sense of what a system can look like. Here's one more where they're mounted on the superstructure. Of course, that's a good way to do it when there's a superstructure available. Next, I'll show a short video here of large-scale fire tests that were performed in the LASH FIRE research. I'm running this in fast motion to save time. But these tests were conducted to simulate a freight truck fire sandwiched between 2 other freight truck containers on a simulated weather deck. There was a series of tests done with different parameters, some with 1 single fire monitor reacting, some with 2 reacting from different angles. And then tests were performed both with a 30-second pre-burn from the time that the fire that you see here reached above these structures, where a detector would detect them, and that simulated rapid intervention by an autonomous system. And then others were done with a 5-minute pre-burn. And the basic takeaways from these tests, and I have more footage if you'd like to see it. Here's a 5-minute pre-burn, by the way. Massive fire. The takeaways are that, as expected, rapid 30-second intervention was much more effective than waiting 5 minutes. And also that using 2 monitors from opposing angles was significantly more effective than a single monitor. It was also established that even a single monitor was able to successfully cool and contain even the 5-minute pre-burn fire tests with 1,250 liters a minute at 5 bars. But again, 2 monitors were able to do that much faster and even extinguish that fire very quickly. The LASH FIRE study also looked at a fully autonomous fire suppression system that was developed by Unifire as part of the project. Again, that system is called Flame Ranger, and I'll discuss a little bit about those autonomous systems now. Here's a graphic where you can see 2 flame detectors, which are used because the system is then able to get 2 separate XY coordinates from each of those detectors, and by having them mounted in an appropriate way, you get vectors from both, and then we're able to triangulate the 3-dimensional size and position of that fire and track that in real time. So we know exactly where that fire is, how it's developing or moving or spreading, and then the system is able to address that based on where that fire is. And then you see in the lower left-hand corner, you see the electronics, or the PLC of the system, which has advanced electronics and software which are able to do that triangulation, make all of the calculations necessary, and aim the water stream intelligently to suppress that fire by aiming the water stream around the fire to keep the surrounding vehicles cool and wet, and then, of course, sweeping over the fire itself as well to suppress it and hopefully even extinguish that. You also see here a number of remote control devices, and it's important to point out that fully autonomous systems, although they do react fully autonomously, they detect the fire, determine its location, and suppress that fire without any human intervention whatsoever. Still, a human operator can take control at any time with a remote control device, 1 or more remote control devices. So here you see they can be controlled, of course, by computer from the bridge or other location. They can be controlled from a tethered CAN bus joystick, from a wireless radio remote control, or from an app for an iOS or Android device, etc. So again, the idea of an autonomous system is to detect that fire, locate its position as accurately as possible, preferably in 3-dimensional space, then to aim the water cannon dynamically and intelligently to suppress that fire around it and on the source, and to do all of that within seconds from detection. Moreover, after the fire is no longer extinguished, the system will autonomously shut off after a pre-programmed amount of time. Typically, it's recommended that it continue to suppress the area for 5 minutes after the fire is no longer detected. But then it shuts off autonomously, and again, a human operator can take over at any time. Here I will show a film of testing that was done in the LASH FIRE project of the system's ability to detect fires autonomously, locate them, and suppress them. And here you're seeing footage from these tests. Again, there's no human intervention here whatsoever. Here, a single system is being tested. There are actually 2 systems on this setup, which is simulating a 30 by 50 meter section of a weather deck. Here you see one of the flame detectors. There's one at each corner of this area. And again, the 2 detectors are giving us the coordinates, and the system is then triangulating the 3-dimensional size and position and tracking that in real time. So you can see the system was proven to be able to detect all of the fires that were lit in a series of tests that went over a week. And you'll see here that the water is oscillating. It's not just aiming directly at and staying right on the fire, which it could do because it knows right where that fire is, but instead it is intentionally sweeping back and forth around that fire, both vertically and horizontally. And here you can see how fast the system can react. So the fire started 6 seconds ago, 7, 8 seconds. So typically in under 10 seconds or 15 seconds, we have water on that fire from the time that flame is detected. So very, very rapid. Again, tests were also done with 2 systems, both operating fully independently. You can see that working here. And again, that's a much more efficient way to suppress the fire. Here you can see some more of the tests that were done with both systems. Again, fully independent of each other. They're not talking to each other or networked. They both see the fire and they're both reacting to it accordingly. Very, very efficient fire suppression is achieved. And all of these were done at 1,250 liters a minute at 5 bars, including the full-scale fire test that I showed you earlier. Next, part of the LASH FIRE system, or the LASH FIRE research, was to do an onboard demonstration of the fully autonomous system. So this was done on the Stena Scandinavica in June 2023. And here you can see the position of the fire monitor in the center. Again, that's mounted to the superstructure, as would be typical in an installation. And there are 2 detectors mounted where you can see the arrows pointing. They're very small, so they're hard to see in this picture. And again, of course, the system had a remote control, but that wasn't used at all during the tests. It operated fully autonomously without any human intervention. So the tests were conducted. There were 12 separate fires lit in random locations on the weather deck. And there's a full report that I'd be happy to share with you on these tests that were done. But the conclusions are that in each of the 12 fire tests, the autonomous fire monitor system was able to rapidly detect that fire, determine its 3-dimensional coordinates, and accurately guide the fire monitor stream of water to suppress the fire by oscillating over and around that fire. Moreover, the system actually extinguished all 12 fires in under 15 seconds each. Next, I'll be turning now to the new Solas regulations and the Fire Safety Systems Code. These were approved in June 2023 and are expected to be adopted in May 2024. And the regulations apply slightly differently to existing ships and those built up until the end of 2025, as opposed to all new build ships starting January 1st, 2026. So for existing ships and those built up until before, I should say, January 1st, 2026, they should be protected by fire detectors according to an MSC Circular 1615, paragraph 2.4, although it's not mandated. I would argue that it would be unwise not to have detection on the weather deck, because if you don't detect the fire, it's going to grow and grow and grow until someone finally sees it, and that may be way too late to address. So of course you should have detection, but it's not mandated for the ships built before January 1st, 2026. But the new SOLAS regulations do require that they be protected by fire monitors, and they must be in compliance by January 1st, 2028. So for all new build ships starting January 1st, 2026, they shall be protected both by fire detectors and fire monitors. So regarding the detection, the wording is that a fixed fire detection and fire alarm system shall be provided for the area on the weather deck intended for the carriage of vehicles. The fixed fire detection system shall be capable of rapidly detecting the onset of a fire anywhere on the area. So this is quite generally worded, and and I think that's good in a way. It allows different detectors to be used. It says the type of detectors and their spacing and location shall be to the satisfaction of the administration, taking into account the effects of weather conditions, cargo obstruction, and other relevant factors. It also says that different settings can be used for specific operation sequences, such as during loading or unloading and during a voyage, in order to reduce false alarms. Again, I'm sure that wording relates to thermal imaging camera systems, which often experience false alarms during loading and unloading. So the regulations allow for that use, but again, looking at the LASH FIRE study, which did in-depth research on a number of thermal imaging camera systems, a number of different flame detection systems, and other detectors. And again, I can provide the report. It's clear that the recommendation is that flame detectors be used. In terms of suppression, for ships built before January 1st, 2026, the regulations, this is Solas Chapter 2.2, Part G, Regulation 20, Paragraph 6.2.3, states that for passenger ships built before January 1st, 2026, a fixed water-based fire extinguishing system based on monitors shall be installed in order to protect the areas on the weather decks intended for the carriage of vehicles. The monitor shall be located in positions which ensure unobstructed protection of vehicles in the area on the weather deck intended for the carriage of vehicles as far as practicable. Operation of the monitor shall be ensured by safe access ways or remote control. And each monitor shall be capable of flowing at least 1,250 liters per minute. And then there's a little wiggle room if monitors are already installed, one can apply and try to make a case that it's sufficient. So there's a little bit of wiggle room here. But the long story short is there must be fire monitors to protect the entire weather deck. For ships built on or after January 1st, 2026, they shall have fire monitors that are in compliance with the Fire Safety Systems Code. So there's a new paragraph in the Fire Safety Systems Code which relates to this. It's Chapter 7, Paragraph 2.5. And it says that the fixed monitor shall be capable of delivering water to the area of the weather decks intended for the carriage of vehicles and the area including the superstructure boundaries located up to 8 meters measured horizontally from the area intended for the vehicle storage or the next vertical boundaries, whichever is less. Also, there's a total capacity requirement of 2 liters per minute per square meter of the protected area. And in no case shall the output of any fire monitor be less than 1,250 liters per minute. It also says that even distribution of water shall be ensured. And then there's a little bit of other language that I invite you to pause and read if interested, but those are the main takeaways. Conclusions from the new Solas regulations and FSS code. And there's a lot of details beyond what I'm explaining, and I'll be happy to explain that further if you have any questions. But the long story short is that ships built before January 1st, 2026, and that's all existing ships, there's several thousand of them, they should be protected by fire detectors, although it's not mandated, and they shall be protected by fire monitors. And they must be in compliance by January 1st, 2028. So that doesn't leave a lot of time, actually, to start planning and outfitting the weather decks of several thousand ro-ro passenger ships. And then for all new builds, starting January 1st, 2026, they shall be protected by fire detectors, and they shall be protected by fire monitors. So my recommendations for compliance for both new and existing ships, based not only on the new Solas regulations and FSS code, but also based on the reports and my experience in the LASH FIRE project, is that the weather decks shall be protected by triple IR flame detectors as the primary detection system, and preferably with the ability to locate that fire for autonomous function. I'll mention that again in a moment. Also recommended that there be a thermal imaging camera system to observe the weather decks so that the crew can see if there's any rapid heat buildup that would not be detected by flame detectors unless there's a flame visible to them, or other hot source on the weather deck. Then the crew can go and investigate and suppress that problem if needed. Next, that remote controlled fire monitors be used, not manually operated, physically manually operated monitors, unless they're already well positioned and in a safe place, because you need to have safe access during a fire. You don't want crew to be running up ladders and then getting trapped by a fire as it grows quickly. Moreover, by having remote control, that allows the positioning of the fire monitors to be put up high, including on the water pipes, as I showed, which may be necessary in order to provide the sufficient amount of water to the weather deck, and to do that from multiple locations. Again, as I mentioned, there should be 2 fire monitors that are able to reach any fire anywhere on the deck. And that means typically it'll be much more than 2, 4, 6, or 8 monitors, depending on the size of the weather deck, but that any area on the weather deck can be suppressed by 2 monitors from different angles. Again, both the monitors and the detectors should be placed up high, 7.5 meters or higher, so they both have a good view and suppression of a fire. And next, since you have detectors and since you have fire monitors, why not also have the autonomous function? It's a negligible additional cost. You're just basically pairing the detectors that you have with the fire monitors that you have, and then you're able to very, very rapidly address that fire. And as I mentioned at the beginning, time is of the essence when it comes to firefighting. So you need to be able to find out that there's a fire and where it is and put water on that immediately. And autonomous systems allow that to happen while basically just being state-of-the-art electronics and software that are able to do that. So that's our recommendations. And that concludes the presentation. Thank you for your attention, and please contact me if you have any questions about the Solas regulations and FSS code or the LASH FIRE project. I'm happy to point you to the numerous reports that are public at lashfire.eu, but even specific sections. So if you have questions, I'll be happy to direct you to those. Again, my name is Roger Barrett James. Please feel free to contact me at roger@unifire.com. Thank you very much.